Welcome to Tepi Talks. So we are still moving on with principle 425-1, and today we are going to go to the new topic, that's coordinate geometry. And under coordinate geometry, we are going to look at areas which even you have ever looked at ordinary level, but here we're just building on more and more things on it. So under coordinate geometry, we are going to look at the length or magnitude or distance between the points. So that's one. Number two, we are going to also look at the midpoint. The midpoint between the points. Number three, so we'll also look at the gradient. The gradient of the line. Number four, we shall look at the equation of the line. The equation of the line, either on a perpendicular line or parallel lines. So we're going to look at these areas. So we are going to center on all these things, and want you to pay attention as you're going to start with them. So we are going to start with the lengths. We are going to start with the lengths between the 2 points. Between the 2 points. So when you find the word magnitude or length or distance, all of them, they are the same under coordinate geometry. So you can say consider the line AB with A x1 y1 and B x2 y2 as shown below. So if I've got our straight line as a line AB, if I have this line and this is my point A given as x1 y1, this is point B as x2 y2. So how can we get this length of the line AB? The length of the line AB is given by the formula. Can say AB, when we put that bar, we are talking about length, is given by a big root of, we look at the change in the x coordinate first. You can either say x1 minus x2, or somebody can say x2 minus x1. It will depend on what is better for you. You can say it's given by x2, we can say x1, x2 minus x1, the whole of it squared, plus y2 minus y1, the whole of it squared. And the unit, it is measured in units. So this is how we are going to be obtaining the length. You look at the coordinate form which has been given, like the first coordinate is given as x1 y1 and B is given as x2 y2. So when you are getting the lengths between these 2 points, we look at the difference between the x coordinate when all of them are squared, plus again the difference in the y coordinates when also they are squared. So under the root of it, then when you go ahead, you try to get its maximum and reduce your answer up to the maximum. As you're going to start with the example under it. And start with example 1. Find the lengths between the following points or coordinates. You can start with part A. You can look at 3, 4 and 7, 9. Part B, you can look at 2, -1 and 5, 6. Part C, you can look at 7, 2 and 8, 9. You can look at our solutions on this. So the first one is, we are saying that find the lengths between the following points or coordinates. So I've got part A. Part A, we are having 3, 4 and 7, 9. You can see these are coordinates, and you know coordinates are in the form of x and y. So the first coordinate is given as 3, 4. Can try to baptize and say this is x1, this is y1. So we have got the second coordinate. We can call this one as x2, y2. So if we try to have our line here, as this is, you can call maybe this is point P, I can call it 3, 4, and this is my point Q, I can call it 7, 9. So when you are getting the lengths between the line PQ, it will give it as root of, and since you have got two coordinates, you can even baptize them. You can say the first one is x1, this is y1, this is x2, y2. So we are going substituting. What is, you can even say x1 or x2, it depends on what is good for you. You can say x2 minus x1, the whole of it squared, plus y2 minus 1, the whole of it squared. So what are we getting? We're getting root of, what is x2? Our x2 is 7, we say 7 minus 3, the whole of it squared, plus y2 is already 9, say 9 minus 4, the whole of it squared. So can we go ahead? What is 7 minus 3? 7 minus 3, we are coming out with so we are getting PQ is given as root of 7 minus 3, we are getting a 4, and when you say 4 squared, can even say 4 squared plus 9 minus 4, we are getting a 5, which is a squared, and what is 4 squared? That is 16 plus 25. So when you try to add, we are coming out with 41. So this is PQ. If you can reduce it, you can still press on your calculator and you come out with exactly the answer, and it is given as units. So let's go to part B. Part B, we are also having 2 points. You can even, if I have this is my line, and you have got, can call this is A, 2, -1. This is point B as 5, 6. This is x1, this is y1, x2, y2. So how can I get lengths AB? To get lengths AB, I can say root of, I can this change in x coordinate, you can say x1 minus x2, the whole of it squared, plus y1 minus y2, the whole of it squared. Even if you start with x2, they will still bring the same. So which is the same as root of, what is our x1? Our x1 is a 2 minus a 5, the whole of it squared, plus, what is our y1? -1 minus, what is our y2? Is a 6, the whole of it squared. So can we try to go ahead and we expand? So we are coming out with the root of, 2 minus 5, we are coming out is negative 3, and negative 3 squared, we are getting a 9 plus. Negative 1 minus 1, we are getting negative 7. And negative 7 squared, we are getting a positive 49. Now when you say 9 plus 49, we are coming out with root of 58. That is AB, and we say units. If you want to go ahead and press on your calculator, still has no problem. If you are leaving it in SADC form, still there is no problem with that. Then we are also moving to part C. We want to move to part C, and we see how we can come out with it. If we have got the line, this is, you can call this is point A, is given as 72, and I've got point B as 8 and 9. So how can we get length AB? Length AB is the same as root of x2 minus x1, the whole of it squared, plus y2 minus y1, the whole of it squared. We are getting root of, do we know x2? x2 is already 8 minus 7, the whole of it squared, plus, what is y2 is already 9 minus 2, the whole of it squared. So what are we getting there? We are coming out with root of 8 minus 1, that is 8 minus 7, that's 1, 1 squared remains as 1, plus 9 minus 2, you are getting a 7, and a 7 squared, you are coming out with 49, which becomes root of 50. This one, even I can reduce it into a smaller root. So AB is the same as, recall from studies, think of two numbers, when you multiply, then we get 50, and one of them must have exact root. So we have got 25 times 2. Do we know the square root of 25? It is 5, then root of 2. So that's what you can say. I've already come out with that, units. So that's what you can do as far as getting the lengths is concerned. As we have tried to look in the first example, now we are going to proceed to the second example in the next video.